Hi, this instructional video is about scientific notation, and this time it is about multiplying and dividing. Here's how this works. In this case, the direction says to change it to a scientific notation. So here's 30,000, so we need to have a number times 10 to the, well, we want this to have a decimal right here. So that means we need to move it 1, 2, 3, 4 to the right. Okay? There. So whatever this was, if you add 4 to the right, it'll go back to the original. Times the second one. Now this one, the decimal needs to go over there on the right side of the 6. So it's 6 times 10 to the, well, to bring back the 6 to the original real number, decimal number, it has to go from here, 1, 2, 3, 4 to the left. So 10 to the negative 4. So there it is. Now it says to simplify and write the results. So the rule is this. Multiply the 3 and the 6 together to become 18. Times, and now you're multiplying the base is 10, and since the 10s are the same, you add the exponents. So you get 10 to the 0 power. Now I know some of you remember the rules about exponent. When anything raised to a 0 is a 1, but wait on. Just a minute. That 18 is not a scientific notation yet. So to make it, you have to move the invisible decimal that's on the right side to the left one. So you get 1.8. And to bring that back to the way it was over here, you have to go 10 to the first power. So that is your scientific notation when you multiply these two numbers. Now, the last part of the instruction says to make in decimal form. Well, that's easy. Simply take 1.8, and it says to move the decimal 1, and since it's positive, to the right. So the final answer becomes 18, and that's the decimal form, 18.0 if you want. So now I want you to try this guy. Okay, so you say 520. Well, you need 5.2. And to take that 5.2 back to 520, you need to move it 2 to the right. So it's 10 to the second power. Very good. Now this small number, we need to make it so that it's 8.67 times 10 to some exponent. So if the 8.67 is over here, to bring it back to the original, you have to move it to the left. 1, 2, 3, 4. So it's negative 4. Yeah. Now that's the scientific notation. Okay? And then write the result in scientific notation. So that means you have to multiply 5.2 and 8.67 to speed things up. Let's use a calculator for that one. So we have 5.2 times 8.67. And that gives me 45,084. 45.084. Now you know that's not a scientific notation, so we have to fix that. But this is the original of what we want to achieve. I'll explain what that means in a minute. Now we have a base 10, base 10. When you multiply the bases that are same, you add the exponent. 2 minus 4 is negative 2. But now since this is not a scientific notation, and it wants it in scientific notation, we go 4.5084. Okay? And so to bring that back, well, since we move to the left, we have to say 10 to the negative 1. Okay? And that is a scientific notation. The solution part of it. Now we have to change this to the decimal form. So we're going to go ahead and take 4.5084, and it says move it to the left one. And so we go left. So it becomes 0.45084. And that is the decimal form solution part of this problem. Now, let's go over to these guys over here. Oh, broken pieces. So here we have now division to move the decimal over here. So that's going to be 3.7. But to make this back to the real number, we have to go 1, 2, 3 to the left. So it's 10 to the negative 3. Okay? You have to move 3 to the left to bring it back to the original decimal form. That times the second one. Now, 0.0026, it has to come over here between the 2 and the 6. So 2.6. But to take that 2.6 back to original, 1, 2, 3 to the left again. So 10 to the negative 3. All over. Now that's a big number, 120,000. But there's an invisible decimal they don't see here. It has to come over here between 1 and 2. So 1.2. This time, to take 1.2 back to the original, we have to move it 1, 2, 3, 4, 5 to the right. So it becomes 10 to the positive 5. And 0.12, well, this has to move to the right one. However, you don't say 10 to the positive 1, no. Because to bring it back to the original, you have to move it to the left. From here to there. So it's negative 1. So, phew! That was just the first part, scientific notation. Now we have to simplify them. So the rule is we're going to multiply 3.7 and 2.6 together using the calculator. We get 3.7 times 2.6, and that gives me 9.62. Times, multiply the bases, and the rule is to add the exponent. Negative 3 becomes negative 6. All over. Yeah. Now we got 1.2 and 1.2. I know that's 1.44 because that's 2 decimal places. 1, 2. And now multiply the 10 to the 5th and 10 to the negative 1. You add their exponent, becomes 10 to the 4th. So what's the deal now? Well, the deal is, the rule is, now you take this numeric part and this denominator numeric part and you divide them. So let's do that. 9.62 divided by 1.44. Well, actually, you know what? Let me punch that in. 9.62 divided by 1.44. That gives me some huge number. Let's round it up, shall we? 6.6805. So let's say 6.681. So that's equal to 6.681. Times, now remember the rules of exponent? When you have a same basis and you're dividing them, you take the 1 from the bottom and you bring it up and you subtract. So here's what it becomes. So if you have 10 to the negative 6 divided by 10 to the 4, it goes up and it becomes 10 to the negative 6 minus 4. Okay, which is 10 to the negative 10. So that's 10 to the negative 10. And there you have it. Leave it like that. And that is your scientific notation. Now you want to write that in decimal form? Okay. Here's how it's done. You go 6.681 and move it left. How many? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fill out all the empty gaps with zeros. Whatever this is, it's a really, really tiny number. You know what? I don't have a space to rewrite that, so I'm going to box that to say that's my answer for the decimal form. Woo! You try this one. Okay, so you said first thing, write in scientific notation. So that decimal point has to come over here on the right side of the 1. So it's 1.0 times 10 to the, or you could just say 1 times 10 to the, but to make it back to the original, it has to go 1, 2, 3 to the left. So it's minus 3, negative 3. That times, next one, this has to come over here between 6 and 7, 6.7, but to make 6.7 back to the original, it has to go to the left, 1, 2, 3 again. So times 10 to the negative 3. All over. This decimal has to come between 8 and 4. So 8 and 4 times 10 to the, and to take 8.4 back to the original of this real number, you have to go 1, 2, 3, negative 3 again. And this one, this point, decimal point has to come to the right side of the 9, so it's 9.0. Or you could just say simply 9 times 10 to the, well, to make it back, you have to go to the left 3 again. Now the rule is 1 times 6.7 is 6.7. This one and this one. Okay? And 10 to the negative 3 and 10 to the negative 3 is 10 to the negative 6. All over 8.4 times 9. Okay, I could do that right here real quick. 8.4 times 9. That's 75.6. 75.6. Times 10 to the negative 3. Negative 3 is negative 6. Something unusual is going on. So now we have 6.7 divided by 75.6. So 6.7 divided by 75.6. That gives me point, I'll write over here, point. So that gives me 0.08862. Okay? And since the top base 10 to the negative 6 and 10 to the negative 6, they're the same, the rule was to take the lower one, bring it upstairs and subtract. But when you subtract a negative, it becomes plus. So in fact, they become 10 to the 0 power, and there's that. Okay? And what you need to do is, well, you need to make this into a scientific notation. And so what was over here, 0.08862, now the point needs to go over here. This one needs to go between 8 and 8. So it becomes 8.862. But to bring it back to the original, you have to move it left twice. So there's that 10 to the minus 2, 10 to the negative 2. And that's on scientific notation. And of course, to make this into a decimal form, what you need to do is, of course, here, we're running out of space over here. It becomes, well, it means to take that decimal and move it left twice. So it becomes 0.08862. So that is a decimal form.